Welcome to the fourth video about Bali Unit for LotusScript, a unit testing framework developed initially for VoltScript and now adapted also for LotusScript. In the first video, I talked about the OpenNTF project and how the place to look was actually the GitHub project and the releases to get to the code. In the second video, I did a bit of an overview on Bali Unit itself, looking at some of the documentation that's available, including the Bali doc. In the third video, I used this basic tester unit test and ran that and talked through setting up a Bali test runner, Bali test unit, looking at some of the outputs, both as XML and HTML files, and talked about how we output things like variant arrays. In this video, I'm going to go into some of the more advanced functionality of the unit test and how it can be used for more than just unit testing. So I'm going to be using this sample before-after tester script. You can access it here and just copy and paste that into an agent, but here's that already set up. So this is just using a single test suite, so I haven't got a test runner here. It's just going to output a single HTML file for the output. Now, when you're running unit tests, it should be fairly straightforward. There shouldn't need to be anything that you need to run around it. You might want to run some code in between tests in order to test a function with different values, for example. But it should be fairly straightforward to run the tests. When it comes to integration testing, then you'll want to set up some test data beforehand, delete that test data at the end so that you can run that integration test multiple times. There might be some additional things that you want to do before and after each test, for example. Now, in JUnit, that's very straightforward to do. You can use annotations on functions and they'll automatically be picked up. For LotusScript, we can't use annotations, but the approach that we can use is to create an instance of the abstract before-after class and have a standard set of functions within that, whose name we know and expect, then pass that into a test suite, and in the test process, if it has a custom before-after, then we can automatically run the functions for it. So that is using the abstract Bali custom before-after class. So I'm using that here to basically take two private global integers and increment A before each test and increment B after each test. So to do that, I create it's the integer increment before-after class. So I create a class that extends abstract Bali custom before-after. That has 4 methods in it, all subs, before all, which will run before any tests get triggered, before each, which will run before each test assertion is run, after each, which will run at the end of each assertion, and after all, which runs at the end. Now, in the custom class, if we just have a look at that, those classes, those methods exist and they're blank. So if you don't want to do anything in before all, for example, you don't need to include that method. It will automatically go through to the base class, run its before all, which is blank, and just do nothing. So you only have to write code for the methods that you need. Before all, here it's setting them to 0. That's not necessary because the integers are automatically initialized to 0, but I'm doing it just for completeness to have a before all with some code in it. As I said, in before each, I'm incrementing A. In after each, I'm incrementing B, and at the end, then I'm just printing out the details. So as we run through, I've included comments for what the variables would be just for completeness. So we can test B as false, which is basically comparing the integer to a Boolean. Assert equals integer for testing that A is 2, which it should be at that point. The one that is very relevant here and worth picking up on is this test here. Now, I initially wrote this test using A, and it didn't work. And there's a simple reason for that. Because I was asserting that CAA was 4, which, if we look at the comment here, A gets set to 4 in the before each. However, the before each runs within the assertion. But we're converting the value to a double before we pass it in. Now, the order of operation here is that it runs call testSuite.describe, which returns a test suite. Then it runs the CBB. It may even run that before the testSuite.describe, I'm not sure. But it runs the CBB, and it converts that value and gets a result to then pass into the assertion, which means that at the time that this function runs, the assertion hasn't been called, and therefore its before each hasn't been called. It may take a bit of fourth dimensional thinking to get your head around that, but it's something to bear in mind when you're doing that. So that's how to use the before each, before after, before all. There might be times where you want to create a single object that has a run tests method that has a bunch of tests in it. Now, as I've used the framework, I've never really actually used that in reality, because I'll just tend to write the tests in here. I'll write the functions or write the code to manipulate stuff in between, and then write the tests at the end. The other thing to point out there is that there's no error handling here. That's because the assertions capture errors, and there's error handling within each assertion, and if it throws an error, it will error the test. So you only need error handling for your own generic code around it, for if that might cause an error. But typically I will just write the code in the same function as the test suite and just use tests here. But if you want to create a custom tester, then that is using the abstract BaliCustomTester class. It has two methods: add test suite, which seeds the test suite into this class so that you can work with it, and run tests, which is where you write your code. So here we've got the custom tester greater than, which I'd set up before I created the assert greater than or assert less than. As I say, in experience, what I would tend to do is, rather than do something like this, I would just do an assert true and run, do assert true A is greater than B, for example. And that will cover everything that you need. But here I've done it in a custom tester. When you're writing these tests and you're not using an out-of-the-box assertion, then there's a few things to bear in mind. The first one is that you need to manually run the run before each and the run after each, because those will only automatically run with the inbuilt assertions. So from this abstract BaliCustomTester class, we can do me.testSuite to get a handle on the test suite, and then do the run before each, and at the end run after each. Obviously there's just the one test here, but if there were more tests, then I'd do the run before each around each of them. It's only needed if you've actually got a before each or after each. If you're not using those, then there's no point calling that method. But then when you're running a test, then you do the testSuite.describe as normal, and then you do your calculation, and to pass a test, you call testSuite.addResult true, and obviously there's no message to pass in, there's no message to display when it's true, so it's just an empty string as the second parameter. AddResult false then takes a string to display in the outcome. So where we've got these failing, this is the string that gets written as that second parameter. If you want to generate an error, we've got an example of that in the basic tester. Here, for example, this toDoTest method is going to generate an error. So we've got a onError handler just before it. We're telling it to onError resume next afterwards, so that it doesn't go in there again. So doTest will generate an error, and this comes down here, and we call addError. TestSuite.getErrorMessage is a simple function that will just get you a very easy to handle error message of the error description, the error number, and the error line. The second parameter is for a stack trace. So if you want to generate that manually, then you can pass that in. So those are the three ways to pass on to tests. Add result true to pass it, add result false to fail it, and add error to error it. We also have the concept of missing assertions in the framework. If you have a describe and you haven't got an assertion or an add result for it, or an add error, then it will say that there's a test that you set up, but there's no assertion for it, and that will also fail the run. So that's the more detailed usage for a test runner. How do you actually run errors in the code? How do you do mocking, for example? Well, we cover off mocking in the documentation in the FAQs. In Java, there's the Mockito framework, and that works because you can always subclass a class in Java. You can set it up to intercept API calls. We don't have that flexibility with LotusScript. So the way that I've found to do it, and the way that I found that works, is to actually put your test suites, your test suite code in the same place as the code that you're testing. That then allows you to use private variables for example, force error is one that I've used. And then if I want my code, if I've got a function that I want to test that's got error handling in it, and I want to jump into that error handling, then I'll set force error to true in the test suite. And in the function itself, I'll have somewhere in there where I'm checking force error, and if force error is true, generate an error. So it allows me to test the error code. Similarly, I may have functions that are passing in instances of a class, so that I can then set up that class in a way that, with properties that have values that I specifically want when I am running that test. Now, that may require writing the code in a different way, and actually that is standard for unit testing and actual testing. So if we come across the writing unit tests page, then we have this entry at the end from untestable code to testable. So this get time of day function here, and this is picked up from a blog post about writing testable code that's not for a specific language. It's certainly not for LotusScript or VoltScript. It's a generic blog post about writing testable code. This function is untestable. It's using now, and there's no way to test that unless you change the system clock in between each run or run the test at particular times of the day. That code actually needs rewriting in order to be testable. You need to pass in the time. Now, I notice that this line shouldn't be there because it would overwrite what's being passed in. But without that line there, then this function is now testable. We can create a test suite. We can create a time. Here we're using time number with the hour, minute, second. and we can do call testsuite.describe and pass in the now time and check the string that's being returned. And then we can have a single test suite that tests absolutely every line of that code, all of the various branches of the if statement. So it may require writing your code differently, but that is standard for unit and integration testing. Finally, I just want to come on to another use case for the unit testing framework, which was not intended, but it's something that I have used in VoltScript code, and that is validation. Obviously, if you're running tests on an object, then you are basically validating that that object is set up how you expect it to be. So if we have a property on the test suite for suppress report equals true, then we can actually ensure that it doesn't output the HTML and XML and just run validation. So here we're setting up a person object or creating a person class. We're setting up an instance of that object, and then we're running assertions on that object. We're checking that the first name isn't blank, the last name isn't blank, the age is greater than 0, and we've got two different ways of doing that. We're doing assert is greater than and assert true person age is greater than 0. And checking that the age is less than 110. And then we can write that test suite code. We can call if testsuite.ran successfully to check whether the validation passed. If it didn't, then we can go through the test results, and if the outcome is not passed, then we can pull out the error message and throw that as an error back to the user. Now, obviously, this one, for example, the error message is just F name, that it was expected to be expected not to be blank, and it was blank. Obviously, in reality, you'll want to do a bit more clearer naming of the tests, but that allows you to run validation on an instance of a class, a JSON object, a notes document, whatever, and use the unit testing for more than just unit testing. So that covers all of the functionality of Bali Unit. Hopefully it's a framework that you'll find is particularly useful. We're using it very heavily in VoltScript. It's also being used in testing the LotusScript language now as well. So it's at the core of what we are doing with VoltScript. It's at the core of any work on LotusScript as well now. So it's going to be something that's going to be around for a long time to come and used extensively by us. So hopefully it's something that will be useful for you too.